Hi, everybody. This is a new rebalance activity. Today, a dialogue between Alain Ostiz, who's professor at University Gustave Eiffel in Paris, and Harvey Miller, which is professor at Ohio University, now in Columbus. Um, Harvey is a geographer, Alain is engineer, and Alain has been working on something we may call the two-speed walls. So trying to represent and to understand the impact that ultra speed technologies to move people all around the globe may have. So we are very happy to have both of you here. Alain will have some like 15 minutes to present his work and his analysis of this new technology. And then Harvey will have a time to intervene with his own ideas. And then we will have a dialogue between them as well as with everybody watching us. So the subject is two-speed walls. It seems that on the one hand, we wish to live in slower cities, cities where we can have everything at walking distance. This has been now popularized by the 15 minutes city, which is something coming from Paris, actually, the 15-minute city, but is actually very old in the sense that the traffic calm zones, environmental zones, by Patrick Buchanan, this is something that we know from a long time, the idea of the neighborhood of the small town where you have everything at walking distance. So the idea of proximity is because you know things which happen all around and you don't rush. But on the other hand, it seems that we like these slow cities to be hyper connected global scale, not just for transmitting information or data, but also to move ourselves, to go from one place to the other as soon as comfortable as possible, like the kinetic elite is doing using private planes. Now, SpaceX and Elon Musk has been thinking on the idea of using rockets to fly in 30 minutes from large megalopolis all over the world. And of course, this is kind of creating a world where you combine very slow, the wish for slow towns, hyper-connected globally in ultra speed technology to move people all around. So this in a way is a demonstration, a kind of a actual implementation, let's say, of the thesis by Manuel Castells of these distances which are subverted by modern technology. But also we can go even to Martin Heidegger to see how the distance is in a way transformed by technology. So the subject is really important for us. I will say it's fundamental for us working on the rebalance research. So we are very happy and honored to have here Alain and Harvey sharing with us their work and their thinking about. So Alain, please.
Thank you, Andreu. Thank you very much. And hello to everybody. I hope you can see my screen now. Yes. So yes, I'm Alain Lustis, and I'm not an engineer. I'm more a geographer. Andreu, so I'm a geographer at University Gustave Eiffel. I'm research director there, and I will present you a topic on the 15-minute city and in a 30-minute world, a topic on the representation of future geographical time space. And I intend to make my presentation in just 15 minutes. So let's see how it works. So I will basically talk about the context, but Andreu already said a few words about this. And basically, my presentation is about investigating, studying the properties, representing geographical time space. So the context of this presentation is effectively the fact that we can hear in the current urban reflection a concept that is gaining a lot of traction sorry. And as Andreu said, it's not a completely new concept. The 15-minute city, this is put forward to reduce car use in cities, to reduce the CO2 footprint of urban mobility. And what is it exactly? It's an idea of having around us, around our homes, baskets of urban functions that should be accessible with very slow to very slow transport modes, walking, cycling, small electric vehicles, that sort of mobility. And at the same time as we have this reflection, we have at the other end of the spectrum, I would say, SpaceX, this company by Elon Musk. I hope you can see the video on your screen clearly. So it's a video that was released in 2017 by SpaceX. And they announced in 2017 that from 2026 on, they intend to introduce agglomeration to agglomeration, city to city, point to point Earth transport with rockets. And this fascinating image. And by the way, I make a very small parenthesis. We are in the context of rebalance, a new culture of mobility. And we know that in culture, we have media, we have images that contribute to forging culture. So images that we have here are also interesting to study in this sense. What SpaceX wants to do is Los Angeles to New York, which is 4,000 kilometers. It's 5 hours by regular jet now, but it would be 25 minutes. London to New York, 5,500 kilometers, 8 hours by regular flight, transatlantic flight, 8 hours. It would be 29 minutes, and so on. So the question I want to raise is, what does it do to time space, to geographical time space? So that's what I want to investigate. And to understand what is geographical time space, I want to just come back to two major questions of geography, which is, where is a place, where is it, and at what distance are places to each other? That's two of the most fundamental questions of geography. And when we say distance in geography, it always refers to movement. So to movement between geographical places. And this is mainly characterized by time and not by kilometers so much, really by time. How much time do we need between places? So a geographical time space is a geographical space associated to a time scale. This concept of geographical time space has a list of properties that I will list here. And the first property of geographical time space is the idea of acceleration. Here we have a mosaic from Tunisia, 1st century after Christ. It's Ulysses and the Sirens, okay? But what is why I put this mosaic here is, on top of the mast of this Roman vessel, you have a tiny triangular sail. It's an improvement of transport technology that was introduced at this period. And Pliny the Elder, it's an historian, a Roman historian, observed, recorded at that time an acceleration of the movements in the Mediterranean area. And we know, at least since this period, we consider acceleration as a marker of modernity. It's really a marker of modernity. And possibly, it will be difficult to get rid of this marker of modernity. It's just maybe a first question in my presentation. So first idea, acceleration. So acceleration is we improve, we introduce new transport systems. Okay, we have new transport systems, but what the study of the history of transport tells us is new transport systems don't remove the old ones, usually. and the idea of coexistence of several transport modes is really rooted in this history of transport. And I take this example of Concorde, so the supersonic transport, that some observers may have been thinking that this could replace completely the classical jet aircraft. It didn't. It didn't survive the classical jet. So this idea that several transport modes coexist with different speed is fundamental and has to be kept in mind. The third property of geographical time space is the idea that it's made of networks. All sorts of networks, uh, airline networks, road networks, but also, if we go back to history, it can be streams, current, all sorts of valleys, and so on. Networks are very interesting and very useful for transport, but they generate shortcuts and also detours, and access points. And talking about detours, so we don't live in a Euclidean world where we don't move on straight lines, and we used to do a lot of detours in our movements because it's more convenient, because it's faster. And on this graphic, you have all sorts of detour until the most extreme form of detour, which is spatial inversion. And spatial inversion is the fact that if I want to go from A to C, I will start my journey by going backwards to B because I access a faster transport system there. And it has deep implications because space is transformed there. And it we can explicitly relate spatial inversion to an issue. When we introduce new transport system, it usually do not be between A and C, we introduce a new transport system. This does not necessarily benefit to the space in between. So this is the idea that I will keep in mind. And we will now look at different representation and see how these parameters, these properties are observed, are checked or not. And the first one I want to discuss is the iconic McHale image of 1969. So it's an image that is falsely credited to Dickens. Dickens is a writer of a series of books extremely popular among academics in the 80s and the 90s, Global Shift. There's more than 10,000 citations of these books in the scientific literature. It's closely related to Castell's 1996, The Rise of the Network Society. So it's really an idea of the shrinking of the world when we successively introduced horse-drawn coaches, sailing ships, locomotive, steamships, propeller aircraft, jet passenger aircraft, and at each stage of history, we have this shrinking of space. And after what I've said about geographical time space, it's clear that we have this idea of acceleration there, but we don't really care for this idea of coexistence of transport modes. We don't care for networks. We just show spatial extent, and we don't care for spatial inversion. So there is here a false message, an erroneous message that space in between cities benefit from acceleration. So there were attempts to deal with these issues, and especially is what some calls plastic spaces anamorphic cartography. Here an example by Spiekermann and Wegener, 1984. So it's considering the surface of the Earth as a rubber sheet, as a plastic surface. So you move locations on the plastic surface so that their distances is more fair to the time distance you can measure. You can have the movement of acceleration between 1993 and 2010. This was basically the high-speed rail transport network of Europe expanding and making places closer, cities closer each to each other. So we have more the idea of coexistence of transport modes. We don't have networks, and especially we still don't have the spatial inversion. So again, we still vehiculate this wrong message that space in between cities benefits from acceleration. This is why I contributed to introducing an alternative model, the geographical time space shriveling principle, introduced in the 90s. But we have recent developments, and this is image you will see from now on. This model uses a third dimension. So to draw simultaneously and coherently a fast transport system and a slow transport system on the same origin destination A and B at the same time space scale. The model transforms the surface in a series of cones. So the time-space surface is made of cones that have a slope, and the steep of the slope is given by a ratio between terrestrial speed and the fastest existing speed. There is a clear metaphor here of the organic transformation of the foot, the patient foot on the right. So you have a surface that keeps its extent, but has a movement of shriveling which creates new connections. In this model, so we have, again, the acceleration, we have the fact that we have several transport modes, we have networks, and we have the spatial inversion, because if it's clear from the image that if you consider a place close to A, between A and B, it's more convenient to go back to A to take the faster transport system with an access in L. So you have here a more fair representation which is more fair to the reality of time space, to the principles of geographical time space, to the measurements of geographical time space, and possibly to the experience of geographical time space. This is what this generates on the time space of the Earth. The current geographical time space of the Earth has two transport systems, airlines at 750 kilometers per hour at long distance, terrestrial road transport at 70 kilometers per hour. Sorry for Harvey, I didn't translate it in miles per hour, but I hope you will catch the idea. So we have an image of the Earth as a series of cones connected. Each cone bears a city on top, so it's really an image that emphasizes the role of cities regarding global time space. Cities are seen here as hubs for fast transport system, and terrestrial time space is completely structured by metropolises. And the next step of my presentation is to reproduce the reference to the McHale image. So McHale, the shrinking world. So the idea of the model of the shriveling world is that the world is not only shrinking, it's also shriveling, as Waldo Tobler coined it when he described this model. So this is the Earth from 1940 to possibly 2040, global time space, with the different transport modes of the fastest possible connection on the left-hand side of the slide. And we will be going from 500 kilometers per hour with a propeller aircraft in the 1940s to 750 kilometers per hour. A parenthesis where it was possible to fly at 1,500 kilometers with the supersonic Concorde. And then SpaceX proposed to introduce the 17,000 kilometers per hour with rockets, and it's very difficult to visualize on this representation. This representation is all at the same time-space scale, so we need to zoom in on this, on what's happening to the Earth with SpaceX rockets. We see here, after this zoom on the 2030 situation, in red, the rocket connections, the proposed rocket connections. Rocket connections are supposed to fly 23 times faster than current airlines. So current airlines in blue are the long-haul aircraft connections in blue lines are rejected very far away above the surface of the Earth, and rockets completely outperform airlines. So the next step, which will be the last step, is what happens to terrestrial space. And again, another zoom on what's left of the Earth. So here we see all the proposed connections by SpaceX in red, and we have cones. And the slope of cones is generated by the ratio of road speed versus rocket speed, and the ratio is 243. So the cones that we saw in previous slides are transformed into very spiky needles. So we can state that rockets would turn geographical time-space into time-space needles. And another ultimate zoom on London. We have even more zoomed on the Earth. We have 15 minutes in time scale on top, 15 minutes by rockets and by terrestrial transport, 70 kilometers per hour. We have London and other European cities. London, the surface has completely, the Earth has lost its substance. If we refer to the metaphor of the maturing fruit, the shriveling fruit, the Earth has completely lost its volume and even its surface. So this is a transformation of geographical time-space made by that the SpaceX system would make to geographical time-space. So I will finish by a series of observation and maybe of reflections. So this mode of representation is based on the hypothesis that we have a system of distances, which is not obvious. This system of distances connects or contains hyper-fast intercity distances with, by comparison, hyper-slow intracity distances. So as we've seen, the geographical time-space of SpaceX point-to-point rocket transport is making a shriveling of the Earth until turning space into time-space needles with almost no spatial-temporal footprint. Cities would lose their spatial-temporal footprints. It's a brutal shock on geographical time-space. It's a brutal shock on its representation and possibly on its experience. This is also something we are investigating currently. Can we find in a human's mind representation of space that are coherent with that sort of representation? And I will finish with this simple question. Can we encompass altogether a 15-minute city, as we seen earlier, in a 13-minute world? So that's all for now, and I finish with the beautiful graphics produced by our colleagues at MCRIT. Thanks for that, and thank you for your attention.
Thank you, Alain. That's wonderful presentation. I mean, clever, but at the same time, very beautiful, and I will say poetic. because every time I read time space needles, I read as well time space needless, kind of kind of contradiction in my mind, which is implicit in what you are presenting. I didn't know that you were not engineer, even though we know each other long time, 20 years. I can tell you that I'm not surprised anymore of your geographic interest and deep understanding. I'm not surprised of this. Before I was impressed and surprised. I'm just impressed now, not surprised. So Harvey, please.
Well, I want to thank Elaine for his very thought-provoking research that he shared with me, and to the organizer for the opportunity to comment and discuss on this research and the general phenomena of space-time convergence, which is a very profound condition in our modern world, as Elaine appropriately pointed out. I like coming back to this needles thing. I like that because needles are useful, but they also can be very painful. And that's something I'm going to come back to in my comments about how this can be useful, but also is a bit painful. So space-time convergence is utterly transformative for some people and places. That's something we have to keep in mind, and that's something that Elaine is really highlighting quite nicely in this research. Space-time convergence is generated by what geographer Ron Abler called space adjusting technologies. And these are artifacts such as transportation and information and communication technologies that change the nature of experienced space with respect to time, cost, and effort. And consequently, and this is an important part, they redistribute human activities in space and time very profoundly. And this is something we need to basically keep aware of these knock-on or consequences of this type of convergence. This does have a very long tradition in geography, looking at how technologies change the nature of distance. Bill Bungay was mentioned, Waldo Tobler. I would also add Donald Janell, who introduced the concept of space-time convergence in his dissertation in the late 1960s, and has some nice early graphics showing, for example, Edinburgh and London moving closer together over the centuries as land mobility technology improved. But I think one of the important things about what Elaine's highlighting here is that this is not even. This is really shattering geography. Before the mobility revolution of the 1800s, everyone traveled at the same speed everywhere. The cost and comfort would vary depending upon whether it was land or water and whether you were rich or poor, but we all travel at the same speeds. And this is now changing. It's changed dramatically over the last 2 centuries. The world has shriveled as it shrank. We're seeing travel speeds and mobility vary much more dramatically among people and places. A general rule that we see is that as people and societies get richer, they want to travel faster and farther. And we know that we see income and wealth disparities have become very extreme in the world, at least in Western societies. On the global scale, there's been some convergence with people being raised out of poverty. But the growing disparities that we see in mobility speeds also reflect a growing divergence, in speeds. Speed reflects wealth, in other words, and that's something I'll come back to later. It's also worth pointing out that we are also starting to see space-time divergence. We could see that on a relative scale because that's the slopes of the cones and needles. That's where travel is becoming relatively slower, but also at the urban scale in large cities, especially in the global south, but even in larger Western cities like Los Angeles and London, we can actually see space-time divergence as speeds start to slow down because of the collective effects of mobility. So that's one point I wanted to make, is that I think this is a very powerful and useful approach that Elaine's come up with, and I think the visualization technique is clever and elegant and very insightful. But let's talk more about this two-speed world a little bit. One thing we have to recognize about speed is that it requires a lot of energy. It requires a lot of fossil fuels and a lot of greenhouse gases. And the only really way we found to travel fast on the surface of the Earth, or the only way we've really found to travel fast and that is essentially green, is high-speed rail. where we can put high-speed rail because of the frictions involving wheels and rail and aerodynamics and the slipstreams effects and the sourcing of green energy. High-speed rail can be a way to travel fast in a relatively green way. But when we're talking about traveling through the air, that it's not as possible before. Unless we discover some amazing science fiction-like new energy source, there's no way we're going to make rocket travel green. It can't be electrified, and there's not enough cropland to grow biofuels to power that. So we're going to be stuck with fossil fuels for this type of unless again some scientific revolution comes along when it comes to energy, but maybe hydrogen fuels, who knows? But good luck with that. It's also worth pointing out that fuel weighs a lot. So on commercial long distance flights, most of the fuel is there to carry fuel. And that's what would happen with rockets. So we are talking about huge, energy and greenhouse gas impact of this type of travel. The other thing that compounds this is that high altitude emissions are also a problem because of the complex effects that happens in the upper troposphere and the lower stratosphere. And generally, when we look at aviation and we look at its greenhouse gas and global warming impacts, we take the carbon footprint and multiply it by a factor of 2 to 4, depending on the circumstance, to talk about its global warming impact. So aviation impacts, the impact of aviation at the higher atmosphere has outsized impacts on global warming. And that's something we have to consider thinking about high-speed travel. So a challenge for Elaine is that I'd like to see if you could extend this method to try to visualize the energy and greenhouse gas footprint of rocket travel in a similar manner, either independently or in conjunction with energy consumption, to show the trade-offs between the speed and energy required for different modes of travel. I think that's something that could also help provide very valuable insights into this phenomena that we're seeing. Another point I want to make is that high-speed mobility is not for everybody. It's for the elite, but everyone pays the cost. Now, Elon Musk once claimed that rocket travel between cities will cost the same as a flight in economy class. Well, Elon Musk also promised that the Tesla tunnels he built in Las Vegas would be a revolutionary mass transit system, and that didn't happen. So in other words, I wouldn't count on Elon Musk's claims here. I really doubt that it's going to cost the same as the economy flight to fly between New York and Shanghai in half an hour. But even if that's true, there are still huge inequities in flying. The best estimates are that 80% of the world's population has never been on a plane. There was a study that was released recently that it talked about 2018, and it said that 1% of the world's population caused half of the carbon emissions from aviation. 1% of the world's causing half of that carbon emission. And the same study said that only 11% of the world's population took a flight in 2018 and only 4% flew abroad. So this is going to be, commercial aviation already has huge social inequities. Rocket travel is going to be worse. And when we talk about fast speeds, there's also an emerging phenomenon at the urban scale, which is urban air mobility, a travel mode to allow the elite to zip around cities at high speeds in the air, while the rest of us are stuck on the ground in slow speeds. And this should never be democratized. We don't want everyone to travel using urban air mobility. Can you imagine what it would be like if our air sheds were congested like our roads are? Just the noise alone would be unbearable and make city life even more humane than it is right now. So a challenge for Elaine in thinking about how to extend his approach is, again, thinking about another dimension of this. Can we visualize not only the discrepancies among places, but the discrepancies among people in terms of high speed versus low speed travel? And I think that's an important thing to do. I also think that I'd like to see your technique applied at the urban scale, because we really are seeing big discrepancies in speeds at the urban scales. For example, people who drive versus people who rely upon public and active transportation. Also, people who are stuck in congestion versus people who can live in more favorable parts of the city. And also with urban air mobility, that's going to be, there's even going to be more of a discrepancy at speeds, even at the urban scale. Now, a final comment I want to raise in my initial comments is to raise the question, why are we in such a hurry anyways? I mean, what problems are we solving through high-speed travel at such high cost to the planet? High-speed travel has huge environmental and social costs. So why do we need to do this? Do we really want to live in such an accelerated, geographically shattered world? Mobility can have counterintuitive and unintended consequences we don't want, and we must be careful when we're messing with geography this much. And I don't mean to sound curmudgeonly or old-fashioned. I'm not, but we've seen a century of unintended consequences from the automobile and from commercial aviation. What's going to happen with rocket travel? I want to raise a few reasons why we should be cautious about this. One is that it turns out humans don't like to save time. And what I'm referring to here is Marchetti's constant, which is named for physicist Cesare Marchetti. And he noted that cities are constrained by about an hour travel budget per day. So throughout history, the predominant mobility technology constrained travel by half an hour from the city center. And that's been constant through history and geography. So what does that tell you? That tells you that as mobility technologies improve over the centuries for their capabilities for trading time for space, societies didn't use it to save time, they used it to consume more space. So we have to think about that. What are the implications of intercity travel? What's going to be that kind of counterintuitive boomerang effect there? I also would point out that faster travel always leads to binge mobility. When people can travel faster, they want to travel more. It's a type of Jevons paradox, if you're familiar with the paradox named after English economist William Stanley Jevons. He noted that energy or any efficiency savings at the individual level leads to more resource consumption at the collective level. Because if you create efficiencies at individual level, you lower the cost to something, and that creates more demand for it. So these time and efficiency savings can actually be another type of boomerang effect. Also, we have to remember that mobility is at its heart from a collective action dilemma, in the sense that it's rational at the individual level, but irrational at the collective level. It's okay for all of us to want to zip around the world and within half an hour, but if we all try to do it, well, there's big problems. And so we often think about, well, what's the impact on me of this transportation technology? But we have to think about not only the impact on the individual, but the impact collectively. And that's one of the hardest parts about doing transportation research from a social science perspective. And one final comment is that, when we accelerate certain parts of the world, but don't accelerate others, or accelerate certain systems and don't accelerate others, we have the possibility of creating shearing forces, which are mismatches in the speeds between different systems. And this is a form of fragility. This reduces our resilience. Manifestations right now of different speeds among socio-technical systems are things like deforestation, pollution, global climate change. We've basically created some systems that are accelerated, but other systems, especially natural systems, still move at their same slow speeds. And these shearing forces can be very detrimental to the health of our systems and the resiliency of our systems. So these are all counterintuitive, effects that can occur from selectively accelerating parts of the world. So I'm not against necessarily improving the efficiency of transportation or improving the speeds of transportation, but SpaceX, urban air mobility, and other space adjusting technologies, they profoundly change the world, as your approach here is illustrated. And so speed is a tool, and we want to use it wisely and not just apply it wantonly, because it can come back to bite us. And that's what your presentation research raised in my mind. And I want to again congratulate you on this approach, and hope you continue to extend it and look at some of these other implications of a fast and slow world.
Alain, what do you say about all these social and environmental impacts? How would you like to see on your analysis included?
Thank you so much for all these observations. But maybe please, it was extremely rich. Can you just repeat for me one of the last arguments about slow speed of the natural system as opposed to selective speed? Can you please just repeat yourself so that I can catch the idea?
Sure, sure. If we selectively speed up some systems while other systems remain slow, that creates shearing forces, which means the interface, the frictions that happen at systems that move at different speeds. And we can see that with how we've accelerated the world over the last 200 years and the impacts on climate change and on air pollution and our ability of natural systems to absorb the accelerated social and technical systems we've created in the world. We can also see that like cities now have become more difficult to manage because we've accelerated urban life so much that, cities are nonlinear with positive feedback loops. And meanwhile, our approach to planning and managing cities still tends to be place-based, incremental, and linear. So our ability to manage cities has not kept up with the speed of cities. And I would say that's a general truism of human systems.
Okay. Yes, thank you for coming back to this point. So I took notes, and I will try to address, to continue the discussion, and I hope that it can lead to another round. Yeah, just coming back, effectively, we know that geographers know that cities consume space, and they have a footprint. And there's another argument I would add to the arguments you mentioned is also that we experience distant work more and more during the pandemics, and this movement is likely to keep to remain to have an effect beyond the pandemic if the pandemic stops one day. And this is another argument for longer commuting less often, but possibly on longer distances. So the footprint of cities could even enlarge in the current transport system, and with the improvements that we are discussing, it's really the door for another systemic rebound effect, I would say. Yes, about your question, I really love the way you phrase it. What kind of problems do we have to solve to introduce our rocket transport between cities? I think the way it's stated is really, I like it really much. And the point is, I think there is this fascination for speed. And this fascination for speed is I mean, Greek, the Roman period, we have we see this fascination for speed, and if you read Strabon, or if you read Pliny the Elder, he is enthusiastic about and he attributes the acceleration not to this tiny sail that we see on the mosaic, but he attributes it to the fact that we use a new type of fabric for the sail, linen. So he is wrong, and we know now that he was wrong, but he was not wrong to record the acceleration. But the strength of the fascination that acceleration has on us, I mean, it's so profound, so deeply rooted to modernity that I really wish we can find ways to maybe to this, how do you say, to stop the drug. I'm sorry. Addiction, sorry, to quit this addiction. How do we quit this addiction? Because this addiction is really so old. So I really wish we could work on this, and I don't know how. Yes, but I'm coming back on reverse about in your question, observations about urban scale. I have made attempts to do some urban scale representation of this type, and I should come back. As I said, it's an old model now, and we have been working a lot since 2016 on new, because techniques have evolved so much, and visualization techniques have so much evolved, 3D visualization techniques. And so far it was very difficult to produce images with big ratio of high speed and slow speed. And at urban scale, the contrast of speed is dramatic because walking is 5 kilometers per hour. And if you arrive in the city with the high-speed transport system, so if it's high-speed rail, it is hundreds of kilometers per hour. So the ratio is somewhere around 10, 20, 30, 40 times slower. So the traveler arriving in a city from this high-speed transport system. So there is a dramatic effect on urban space, but it's on the table. So I have to investigate it, and it's a very I think it's a promising way to develop the model.
If I can jump in here, you might look at a literature called Urban Fields, and this was developed within regional science roughly in the 70s, and it was basically a totally geometric approach to how cities form. So instead of treating cities like composed of objects or even being an object, it treated the city like a field, and it showed how differences in friction of distance, how that basically leads to different intensities of urban properties. And it's a very interesting approach. It kind of went away because the computer rose up since the 70s, and computers are much better at handling objects than they are at fields. But it's still occasionally you see these ideas raise their head, pop up every once in a while. And it's a very interesting approach. I still have some merit. It's a different way of thinking about urbanity, but it does directly point to the friction of distance and how it warps the phenomenon we call a city.
And it's absolutely right that we connecting urban fields, so fields, also fields of physics, the fields of and new visualization techniques is another way to go forward. Absolutely. Then going back to the discrepancy among places, among people, is true that we can. There's two ways I would like to go further on this argument. Is the fact that the image of rocket transport is an elite geography. It's sure. I mean, I absolutely follow you, and I don't follow Elon Musk. Sorry, Elon Musk. He made some promises that he was able to hold on. Not all his promises were proved to be wrong, but I don't believe this one will work ever, to have a rocket transport for everyone. For the cost of a low cost airline transport, which is, as you said, not for everybody on the planet. So, but maybe the social issue is not so easy to deal with, and maybe what the model was good at conveying is indirectly, especially the fact that not in the rocket geography, but the airline geography and the airline time space, it really emphasizes cities, and it really emphasizes metropolitan space opposed to the non-metropolitan space. So the non-metropolitan space is handicapped and is rejected down the valleys, very below, possibly where other types of people live, not the same type of people that live in cities, but it's more this spatial reading, this spatial analysis that is built in the representation, not as much as a people's representation. The other way to discuss this would also to attach a type of people to a type of network, because it's not easy. And it was a reflection I had when discussing one of the former images about airlines coming to a city. So when you have an airport, it's really a place where you have the jet set going there, and you also have the people who care for security, for cleaning, for all sorts of services around. and they don't move at the same speed. And it's absolutely clear at airports that we have this convergence of people converging. They physically possibly share, they could meet, but they really move at completely different speeds, and the image could convey this.
Well, if I can respond real quickly, I think one way to handle this would be to look at the type of cities that'll be connected by rocket travel. And it's not going to be all cities. It's going to be like the Londons and New Yorks and Shanghais. It's not going to be the Columbus, Ohio's, or St. Louis, Missouri, or any of these others. It's going to be, again, the elite global cities. And this is another manifestation of winner-take-all capitalism, where the really important cities in the world, important quote unquote, are the ones going to get this, and the rest of us are going to be traveling slowly on the ground. So, so I think if you can attach the characteristics of the city to the visualization, you obviously can't attach individual people to flows that easily, or network connections. But certainly the types of cities that'll have fast service and the types of cities that have slow service are going to be different cities with respect to economy and demographics.
There are big surprises in the list provided by SpaceX, because, okay, there's Shanghai, there's New York, there's, okay, London. Already London is an issue, because when you look at the video, the device, the rocket, takes off from an offshore platform. So this, okay, I completely support your analysis of the megalopolis, the top level metropolises, so the winners take all, but it's also those that are located close to the shore and not the inland, because I don't know how you can get to the offshore platform from Paris. How will you go to the platform? I mean, Paris is not on the shore. So London can be discussed, but do you take the fast boat from the Tower of London to where? To somewhere in the North Sea? It's more, if you go to Hong Kong, if you go to Shanghai, maybe the system can operate, and it's quite clear that it will be difficult to imagine that the system will attain levels of safety, security, so that we can land anywhere. I'm not sure.
Mm-hmm.
So, let me ask you, and Harry, one question I have here from Jean Paul Rodriguez, which seems to me really interesting. He introduced the idea of freight. So he says space-time convergence occurs differently in the freight transport sector, where short distances are becoming fast last mile deliveries, while we have three main lanes for long distance maritime, rail, and air, which are slower than for passengers. Therefore, the problem appears to be partially inverted from passengers' mobility considerations that have been the focus today. So is there a duality, different rules, contradictory rules between passengers and freight, which should be actually, because transporting people is not like transporting freight. It should be very different, actually. And in transport studies until now has been very much the same thing. and Jean Paul is telling us that it's actually working differently. What do you think about?
I think that's a great question. I think the rules are different. I mean, one of the reasons why Amazon can deliver something to me within a day sometimes is because they've anticipated consumer demands and stored it in a fulfillment center on the edge of my town. But unfortunately, we can't store people like that and have them move, so that's one difference right there. Also, again, think of geography. Yes, people living in cities can get freight delivered quickly, but if you're off, the logistics network, or you're in a more isolated place, you're not getting it at the same speed. There's also a problem in the United States with freight congestion. I'm not a freight expert, but I understand there's a problem where, even like freight moving across a city like Chicago can take days, even freight that's moving through Chicago. So that's a point I want to raise in all this, I think, which a deeper implication of this question is that we have to remember that transportation is always about atoms, not about bits. And we're always we're always amazed at how we can manipulate bits and make everything more efficient and faster, and it's wonderful. But we have physical limits on transportation and on mobility, and we have biological limits when humans are involved.
Yeah.
Elaine?
Yes, I think it's absolutely true about freight, but it's really, I mean, nevertheless, it's still puzzling. It's still puzzling that we have the instant delivery on one side, the urban instant delivery, and on the other side you have tankers that can block canals, and they are very slow. So it's puzzling. So maybe it's a way. I mean, there's maybe ways, and the point is, but as you say, Hervé, the point is logistics. Logistics is stocks. So stocks, we don't have them in for transport. So. But really, I think it's worth thinking of it. Just wanted to rebound on the idea of physics, and I think simple physics. If a vehicle, if the energy you put in the vehicle is needed to move the stocking of the energy. The electric car is similar to what you said, in fact, because you said we have systems that need fuels, and the long distance aircraft has fuel to transport fuel, so it can fly long, and the rocket would be the same, because the rocket is exacerbated. And I think this opposes the electric car to the electric scooter. And I know that some engineers in my university, they draw my attention to the fact that moving an electric scooter and an electric car, in the electric scooter, much of the energy is dedicated to movement, instead of moving the vehicle, moving the people, because the weight of the vehicle is not neglectable, but is very, very slow, as opposed to the 1 ton electric vehicle. So going back to physics, and maybe strengthening physics in the educational system, I don't know what way forward, but I think going back to physics, to simple physics, could be a very good element. And maybe just coming back, because to one of your remarks, very and we share a lot of literature. We read and we know the same people, of course, but it's true that Janel and Donald Janel, I've been in personal contact with him very often these last years, and he didn't publish in his, I think it's in his PhD, images, graphics that are by design very, very close to the concept that was invented by my own PhD supervisor, Philippe Matisse, in the 90s. Very, very close to but it was hand drawn in 1960 or 70. And so there's a lot. So the Donald Janel, when he coined the space-time convergence idea. So it's really about this. And one of the points of the space-time convergence, which is very smart, is the demonstration that space-time convergence benefits more to the big cities than to the small cities. That's a very brilliant demonstration he made. And it goes effectively, it echoes very strongly what you said about what is this list of cities in the SpaceX video. What the list of cities is really a special list of cities. It's really making a pick of maybe the best, or the biggest, and the most prominent cities of the world.
Yeah, I think ultimately, you mentioned, how do we cure our addiction to speed? And I think we can. I think we have to manage it like all addictions. It has to be managed and mitigated. And we're already seeing that at the urban scale. You started out talking about 15-minute cities, and that's an example of how, and right now in sustainable mobility, the idea is not to keep accelerating in intra-urban travel, but to slow it down in many places, to allow other modes such as active and public transportation to flourish, also for greater safety, because speed is the #1 killer of people in cities because of cars. And so I'm optimistic that we can actually at least manage our addiction to speed. I think ultimately, if we don't, the planet's going to solve the problem for us, and not in a way we like.
And maybe, Andrew, if you allow me to react.
Yes, please.
To what you said, because it's part of our project Rebalance, and it's a big reflection on speed as opposed to slowness. And the way you say it again, addiction to speed, maybe you said not keeping on accelerating, acceleration as an addiction. And I think when you think of, I mean, the way to phrase the message, and we know in psychological, social psychology applied to transportation, we know that the way you phrase a message is important and has an impact. So stop addicting to speed is not is not exactly equal to slow down. It's not the same message. And maybe that's a way to move on in the reflection. Stop your addiction to acceleration. So it's a contribution to the debate.
Thank you very much, both of you. I think we are just about 1 hour. So maybe I can ask you some conclusion or some last insights. Maybe beginning by you, Harvey, and then closing by you, Alain. What do you think, Harvey?
Well, that's fine. I think I really appreciate the opportunity to comment on Elaine's research. I think it's important for us to realize what acceleration and what space-time convergence, differential space-time convergence, is doing to our society and to our planet. So I think it's something that we don't think about, and it's something we need to think about more carefully and be more critical about and manage it better. So thank you, Elaine.
Thank you very much, Harvey, for all your questions, and also Andreu. No, maybe it's an observation you made, and I didn't reply to it, and maybe I would just leave it. In fact, because I don't have an answer. Is you mentioned fuel? Can we or energy? Could we add the energy layer in the image? And so far, I've been failing to do so, because what I put in the model is just time. It's only time. The economist tells us that time can be converted to money, value of time. But so far, I've not been able to find, I've done it, but I'm not convinced by the results of transforming time distance by cost distance in this model. I mean, I think cost distance is very relevant, and I wish we could find ways to introduce energy, the energy layer. And if you have ideas, Harvey, I would be glad to more concrete ideas. I would be glad to continue. And so I just thank you, Andreu and Harvey, for this very nice discussion, and I hope you enjoyed.
Okay, thank you both of you, and to all our people, colleagues, friends watching us. Stay connected, because more talks and more discussions like this we will have in the coming weeks and months. So bye, everybody.
Goodbye.